Okay, now we are going to talk about semaphore. Okay, the semaphore is for the waiting. We have said that in a while loop we will infinitely wait, right? So in order to make sure that is basically satisfied, we're basically using semaphore. Okay, semaphore s is what? An integer variable. Okay, this is the shared variable. Now there is two functions you have to understand, two operations I would say, two indivisible atomic operations are there, that is wait and signal. Wait is like this, okay, also denoted as like v, okay, and signal is denoted as v and wait is denoted as p. Fine. Now here what happens is that if s value, if the semaphore's value is less than or equal to 0 means while in that loop it would still wait there because it is not free when the value is s less than or equal to 0. Here the opposite condition is that if s value is 1 means we are talking about binary semaphore where 0 and 1 is there. When s value is 1 means it is free, okay, and if it is 0, if semaphore's value is 0 means it is not free. Understood? Now wait of s means s less than or equal to 0. In the while loop there is no while, that is until the s value is less than or equal to 0 it does no operation, it is in this while loop itself. Okay, now signal means what? It can enter the critical section and it is releasing. S plus plus means what? It is releasing that. Now the system can be free. That is what signal means. I will explain how it works. So I want to know through this example I will explain. So S is equal to 1 initially. Okay, S is equal to 1 initially means what? The critical section is free. So here the opposite condition. If S's value is 1 means it is free. Now we are going to do weight of S. When we are doing weight of S, we will see, we will weigh. If I'm doing weight of s, in that function if my s value is less than or equal to 0, that means the critical section is busy, okay, but it is not the case. Here s value is 1. S value is 1 means I can exit from this while loop because this while loop is false here, okay, this while loop is false here. So that means my s value would now increment and it becomes what? S equal to 0. So that means it doesn't want to wait here in the while. So here it doesn't want to wait here, its value is getting decreased to 0. So if its value is decreased to 0, s becomes 0, means it enters the critical section. If it enters the critical section and if it finished whatever it requires there, then it will do signal of s. Now the s value again becomes 1. So when s becomes 0 means it is busy. No one can, if any other process comes and if it checks the value of s, s value is 0. So it will be inside this while loop. The s value would not get decremented there. So if s is 0, it will be here. It would stuck. The other process would stuck here. When s value again becomes 1 after releasing the resource, now again this value becomes 1. Now another process comes, it sees that s value is 1, which is breaking from the while. Now s value becomes again 0. Understood? So that is what happened in the do while case. So here first we will wait of s, then if this wait loop is break, if the weight of s, that is while s is less than or equal to 0, s minus minus, okay, so if that loop is break then it would enter the critical section. Now after entering the critical section it will do signal of s. So that means when it do signal of s, that means the s value becomes again 1, the s becomes free again, okay. This is what. Now the how you are going to define the wait function, this is how you are going to define the wait function, this is how you are going to define the signal function. Understood? This is how the semaphore is implemented. You can implement the semaphore using zeros and ones like this, or counting semaphore is there, that is semaphore's value can be variable, s can be 3. That means I can first take the whole when multiple devices are needed. This is when multiple instance we want to access a resource, that resource multiple instance I want to access. Let's say I am accessing, there are let's say 3 printers. So s equal to 3 means there are 3 printers. So first I will access weight of s. First weight of s, if that is completed means I will access let's say printer 1. So s value becomes what now? 2. Then again I will write weight of s means I will access the printer 2, that is x equal to now becomes 1. Again I will say weight of s, that means my s value becomes 0, like that. Understood? So binary semaphore is that is same as mutex lock, like how we are doing. This is the 0 1 case. Now multiple semaphore is what, sorry, counting semaphore is where there is an integer value and it can range over unrestricted domain, right? There is no particular domain for it. Now it is used when you wanted to control access to a resource. That resource, like if you I said printer, that printer has multiple instances, right? So those in which you wanted to control the access to a resource, I'm controlling the access to a resource that is having multiple instances. In that case, when that resource has multiple instances, then in that case we can basically do the counting semaphore. Understood? So this is how the semaphore basically is implemented. Okay, thank you.